The theodolite used in this video demonstration is a Sokia DT5 electronic digital theodolite, which has a reading accuracy of 5 seconds and incorporates many of the features found on electronic theodolites. The first stage is to set up the tripod over the point from which the angles are to be measured. In this case, the point, or station, is marked by a nail which has been driven to the top of a wooden peg. This instrument station will be designated Station A. In this case, there will be 3 other stations which will be designated Stations X, Y, and Z. We put ranging rods next to the stations to help locate them when we are looking through the theodolite. However, the exact station is the nail in the top of the peg. Leave the theodolite in its box for the moment. Undo the tripod and extend its legs, but not completely. Place the tripod approximately over Station A. It is important for you to set it at a convenient height for you to work at, and to make sure that its head is reasonably level by eye. In order to check that the tripod is approximately over Station A, some surveyors and engineers drop a stone or a coin from its center and see if it hits the nail. A better method, however, is to suspend the plumb bob provided from the hook inside the tripod centering screw and note its position relative to the nail. Now move the tripod feet to bring the plumb bob within 10 millimeters of the nail. All 3 feet must be moved by the same amount and in the same direction. This will keep the tripod head reasonably level. While you hold onto the plumb bob, push the tripod feet firmly into the ground. Be careful if the ground is hard. If one of the feet won't go in as far as the others, don't worry. Now suspend the plumb bob once more. If necessary, adjust the length of each leg to bring the plumb bob back within 10 millimeters of the nail. At the end of this procedure, the tripod head should still be reasonably level. Now check that the adjustable leg clamps are tight. This entire procedure is known as rough centering. The tripod now provides a solid and stable platform for the theodolite. Before you take the theodolite out of its box, have a good look to see how it fits in. This will help you when you come to put it back later. When you lift the theodolite out, hold its carrying handle. Never lift it by its telescope. Close the box in case it starts to rain. Place the theodolite on the tripod head. Keep a good hold of it with one hand and tighten the tripod centering screw with the other. Theodolites basically consist of a series of mutually perpendicular axes. The vertical axis, which passes through the center of the horizontal circle, the trunnion axis, which passes through the center of the vertical circle, and the line of collimation, or line of sight, which passes along the center of the telescope through the center of the crosshairs on the diaphragm. Before it can be used to measure angles, the theodolite must be carefully centered and leveled so that its vertical axis passes vertically through the station, its horizontal circle lies in a horizontal plane, and its vertical circle lies in a vertical plane. The first stage, therefore, is to center the instrument over the nail at Station A. Look into the optical plummet and focus the centering index mark. If the index mark is not exactly over the nail, adjust the 3 leveling foot screws until it is. The next stage is to approximately level the instrument so that its horizontal circle is almost in a horizontal plane. Look at the circular level bubble and note its position relative to its index mark. Shorten the tripod leg nearest the bubble or extend the leg furthest from the bubble until the bubble is centered in its index mark. Usually, 2 tripod legs must be adjusted to achieve this. Be careful when adjusting the legs. Always place 1 foot on the metal shoe of the leg being adjusted. This keeps the tripod steady. When the adjustment is finished, make sure that the leg clamps are tight. The horizontal circle must now be brought exactly into a horizontal plane by carrying out the fine leveling procedure. In this particular theodolite, this is done using its 2 main plate levels in conjunction with its 3 foot screws. Free the horizontal clamp and turn the upper part of the theodolite until one of the plate levels is parallel to the line joining 2 of the foot screws. This is position 1. Bring its bubble to the middle of its run by rotating the 2 foot screws in opposite directions. As a guide, the bubble moves in the same direction as the left-hand thumb moves on the foot screw. The other plate level lies in position 2 at right angles to the first plate level. Bring the bubble in this second plate level to the middle of its run using the 3rd foot screw. Check both bubbles. Each should be in the middle of its run. If they aren't, put them in the middle again using the appropriate foot screws. Rotate the upper part of the theodolite by 180 degrees so that each plate level is directly opposite its original position. Note where each bubble comes to rest. If each is in the middle of its run, then the horizontal circle lies in a horizontal plane. If not, use the appropriate foot screws to take out half of the error in each bubble. For example, the bubble in the first plate level is 2 divisions to the right, so put it 1 division to the right. The bubble in the other plate level is 1 division to the left, so put it half a division to the left. Now rotate the upper part of the theodolite through a further 180 degrees back to its original orientation. The bubbles should come to rest at the positions to which they have just been set. The theodolite is now level, since each bubble stays in the same position anywhere in a 360-degree rotation. It is not unusual for bubbles to be slightly out of adjustment. Once you know the positions of the bubbles on your theodolite, you can set them up straight away without going through the full procedure. If your theodolite only has 1 plate level, you carry out a similar procedure by bringing the bubble to the middle of its run in position 1 using the first 2 foot screws, and in position 2 using the 3rd foot screw. You then note where it comes to rest in positions 3 and 4. You then return it to position 1, where you take out half the error using the appropriate foot screws. Do the same in position 2 using the 3rd foot screw. If you now carefully rotate the theodolite through 360 degrees, the bubble should remain in the same position, indicating that the horizontal circle is lying in a horizontal plane. Since the leveling procedure can alter the centering, you should now look into the optical plummet to see if the instrument is still centered exactly over the top of the nail. If it isn't, carefully slide the theodolite over the tripod head until the index mark is exactly over the nail. Then tighten the centering screw. Unfortunately, the act of recentering can upset the leveling, particularly if the tripod head was not initially set very level by eye. So the leveling must be checked. However, the full procedure is not necessary, since you now know where the bubbles should be for the instrument to be level.